Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to the last part of our matrices series, especially for my grade 10 elite students. Today we are finishing the lesson 7.7 Solving Systems of Equations using Inverse Matrices. So in today's session, you will be solving matrix equation. This video is a very important video, an important application. You must watch the video till the end so that you benefit from the concept of solving matrices equation. In today's video, our learning objective would be to write and solve matrix equations for a given system of equations in your exams as an application of use of matrices. This important application of matrix equation is surely going to come. One question will be there, which will be a 2 cross 2 system of equations. So would request you to watch the whole video and benefit from it. Let's get into the video now, and a humble reminder, if you like my videos, if you have found them useful and you want to stay updated with my latest videos, make sure you subscribe and press the bell icon so that you don't miss all my upcoming videos and notification.
Let's see what is a matrix equation and what is its general form. A matrix equation can be written in the form AX equal to B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. Let's take an example to understand matrix equation. X plus 2 equal to 9 and 3x minus 6y equal to 3. So let's just mark these equations 1 and 2 and let us write their coefficients. So here's a correction, y is missing in the first equation, so it has to be x plus 2y equal to 9. So we can write the coefficients as the matrix 1, 3, 2, negative 6, the variable matrix as x and y, and the constant matrix as 2 cross 1, which is having element 9 and 3. So this form is called the matrix equation form, and its solution is given by A inverse multiplied with B, where A inverse is the inverse of A, which you've already learned in the previous video how to find.
In today's session, we will be solving these three problems. Out of these three, I'm going to do the first two for you, which is question 27 and 28. These questions I've taken from your math book from the unsolved problems. And here in these questions, you need to use a matrix equation to solve the system of equations. When we solve question 27, you will be able to see how the system has no solution. However, for question 28, there is unique solution. After you understand these two questions from from this video, make sure you try yourself question 29 to check your understanding, and I've put here for you the final answer -1, 5 that you can use to check your answer.
So let's solve question 28 first. The first and the second equation are written respectively. This is a question from Unsolved Parts of Perseverance taken from Math Book page 58. First we find the coefficient matrix. As explained to you in the example, the coefficients of x are -1, -2, and for y are 1 and 1. Now step 1 would be to find the determinant of the coefficient matrix. So let's find its determinant, and we'll apply the diagonal rule to calculate this determinant. So first we multiply primary diagonal, then we subtract the product of secondary diagonal. Simplify this expression and the determinant of C, or the coefficient matrix, comes out to be 1, which is non-zero. Now here, because the determinant is non-zero, we can say the inverse, which is C inverse, exists. Now let's write the matrix equation. So the equation is Ax equal to B form. So here actually your coefficient matrix is nothing but matrix A or matrix C. So any one alphabet you can use, both are equal here. So in this question, A matrix can be replaced by C matrix, which is the coefficient matrix. So x equal to A inverse B, that's the solution. So that means we need to find the inverse of C matrix and then multiply it with the constant matrix B, which is equal to 3, 6. So let's first find the inverse of C. Formula as from my previous video is given here. So you just interchange the primary diagonal element and change the sign of the secondary element diagonals. And now we are going to multiply it with 3 and 6. Determinant of C is 1, so that is not going to change the answer. Now the solution will just be got by multiplying these two matrices. So let's do the multiplication of this 2 cross 2 matrix with 2 cross 1. The result would definitely be again a 2 cross 1 matrix with 2 rows and 1 column. So we multiply the corresponding element, 1 with 3 minus 1 with 6, and second row would be 2 multiplied with 3 minus 1 multiplied with 6, which gives you negative 3 and 0. Now X matrix is nothing but X comma Y matrix. So now you can make the corresponding parts equal, and from there we get our solution set. So the solution of the system of equation is X equal to negative 3, that's the solution set, and Y equal to 0 because that's the corresponding element. So I hope you have understood well how we use matrix equation to find the solution of a 2 cross 2 matrix system of equation. All done. Let's now do another question. This is question 27, same page 56. Again, we have two system of equation which can be written in the matrix form or the matrix equation form as Ax equal to B. So let's write the coefficient matrix A and then find its determinant. So the coefficient matrix here is given by the coefficients of x and y. So negative 1 in the first column and 1 1 in the second column. That's your A matrix. Now let's find its determinant. So we have to put these big bar brackets and then write the elements inside and find the determinant. The rule for finding determinant, I hope you all can recall, is to first multiply the primary diagonal and then subtract the secondary diagonal. So as you see, determinant is 0. And since the determinant of coefficient matrix is 0, A inverse does not exist. So now that you cannot find A inverse, how can you even think of finding the solution of this system of equation? So we conclude by saying that x equal to A inverse B also does not exist, or the solution set of this system of equation does not exist. So this system of equation, number 1 and 2, does not have any solution. Hope it is clear.
Thank you for watching my video. If you found it useful, give it a thumbs up, like, share and subscribe to my channel, Mathematics Made Easy. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.